with you.
Recording in progress.
Okay, now I think that you can see the shared slides with you. Please let me know. Can you see the presentation?
Yes.
Okay. Okay, today we are going to discuss about uh, the under the electronics, applied electronics, that it is a digital electronic part. And there we are going to discuss about the Boolean algebra. Um, and under the Boolean algebra, the logic gate part is very important. And the truth table of logic gates are directly deal with our part. Mm. So have you gone through the truth tables of logic gates in your A levels? A levels में logic gates truth table करा. Yes. So actually, this the first part of this lecture is a reminder for them. Then the next part that we are going to use the Boolean algebra and how we can use uh, the truth tables and the logic gates circuits for our day-to-day applications. Okay. So let's move on. So okay, the first one is what the first thing that we want to know, what is a logic gate. So there are many kinds of logic gates that we can find in digital electronic. Uh, so this is the normally it's a fundamental building blocks. So in these logic gates, you know that as this is digital electronics that we are dealing with binary inputs and output. So when we give an input as a binary input, that all of these logic gates gives a single binary output. Okay. Then we are using these logic gates. So there you can see some examples: and NAND, O, no, buffer, not, XOR, XNO. So we use these logic gates in various arrangement to achieve various output according to different inputs. But these all are binary. So before going to the truth tables of logic gates, you can see what are the types of logic gates. So here, these are the basic logic gates. Here, these are there are three types, and one is basic logic gates, and the other one is universal logic gates, and the last one is derived logic gates. So, the basic logic gate is has come with the basic arithmetic operation. So, first one is AND gate. So, AND gate is comes with the multiplication, or you can say it's as dot. And the OR gate is comes with the addition or sum, and NOT gate is uh, just like minus, but actually it is the complement. Those are the basic arithmetic operations. This is not subtraction; it is complement. Okay. Uh, uh, so there are three basic logic gates, and then the universal under the universal logic gates that we can find NAND gate and NOR gate. And finally, the derived logic gates means the combinations of these two types of logic gates, and they have a special uh, tasks. That mean normally they are not. They have no a single arithmetic operation, but they are combination of many operations. But by those logic gates that we have obtained the derived logic gates. So those are XOR gate and XNOR gate. So let's see what are the truth tables of these logic gates. But before that, we should know what is a truth table. Okay. So normally here I'm mentioning that the normally a logic gate is not a single component. So you can remember that we have discussed about op amps. So they are um, the op amps is also not a single component. It is a IC. So like that, these logic gates are also IC because they are made of diodes or transistors. So therefore, using many diodes or transistors in various configurations, that you can have a logic gate, and a logic gate expected to be worked on the logic gate truth table. So truth table means now So in a truth table that we show that all possible inputs combinations. So we can give it from 1 or 0, and uh, and we will have the corresponding output for those input also as a result in the truth table. So you should know Um, if there are uh, input n times, that means the all possible inputs are 2 to the power n. So that means if there are three inputs A, B, C means it means that there are 2 to the power 3 combinations. That means 8 combinations. Okay. Uh, So actually, I want to mention you again this logic gate part is very important because you have a full question a full essay question from the logic gates and the Boolean algebra, mm, as well as with Carnap's. Okay. So these are the truth table. So I think these things, but yeah, you can remember. But I added it slide to remember it again because uh, when you are drawing circuits, that these are very important. So this is the first logic gate. It's N, and you can see the symbol. So in this case, that you can see there, you can give two inputs, A and B. And in the AND gate, you get the result A dot B. So as there are two inputs, there you can have four combinations of uh, inputs. So therefore, according to that, you will get this result. If 0, 0, that means if A is 0 and B is 0, 0 into 0 is 0. Uh, so if in this case, you can see only 1 to 1. That means if the both inputs are true, that you get the output as true. Otherwise, it is 0. And OR gate means second one, and there you get A plus B. That means if only the all inputs are false, that means 0, then you will get output as 0. Then otherwise, all the values are 1. So you can the symbol of the OR gate you can draw like this, and the Boolean function is as you can use it as A plus B. And these are the main two basic logic gates, and we can derive NaN and NO from this. So how you can get that? Just get the complement of this AND gate. So then you can have NAND gate. So in the NAND gate, you can see on in the AND gate, the output only get one when the input and output is one. So like that, this is totally the opposite. You know what's mean by the complement. So the complement of 1 is equal to 0, and the complement of 0 is equal to 1. So therefore, yes. This is another NAND gate. And there, when the both inputs are true, you will get the false output. And otherwise, for the all other input combinations, the output is 1. Um, and in OR gate, it's A plus B is O, but in the NOR gate, it is the complement. So therefore, it's the opposite of OR gate. So once you give 0, 0 as, that means false, false for the both inputs, you get the true output, but in other cases, you get all the values as 0. Okay, I think now you can remember these things, and just you can remind the relationship between these two inputs. So it is very easy to understand. And okay, let's move to the next one. Uh, so before going to XOR and XNOR, I'll mention about the buffer and not. So buffer means you can remember in the op-amps part also. So there you could see in buffering means the unit gain. So that means no change in the input. So just like that in the digital electronics, in the logic gate part, the buffer is also mentioned as no change in input. That means if you give the input as 0, you get 0 output, and input as 1, and the output is 1. So in the NOT gate is the opposite. That means it's always gives the complement. So the output is the, if this is the input A, so here in the buffer input, when the is the input A, the output also A. But in the NOT gate, if you give A as the input and you get the complement of the A as the output. So there are two derived logic gates here. So first one is XOR, another one is XNOR. So in the XOR, it's always say when the both inputs are same, you get the output as false. So you can see whether it is the inputs are 0, 0 or 1, 1, you get the output as 0. But in all other cases, it is 1. So the output can be right A dot B complement plus B dot A complement. So you can like write like this. So then you can see when both the inputs are 0, you get 0 output. And when both the inputs are 1, there are also you get 0 as output. But in other cases, you get output as 1. And the XNOR gate, the Boolean output expansion is, this is totally opposite of this XO. So the XNO. So there you can write the output as A dot B plus A complement dot B complement. So there you can see when you are giving the both when you are giving the same input for the both inputs, it means 0 0 or 1 1, you get the output as 1. So these are the logic gate that you should know, and logic gates and the truth tables that you should know. Then you have to you can use them in uh, your advanced calculations. Okay. Uh, so these are things to remember, and as you have already learned this in your A levels, I will just pass this part. And but if you have any confusion, please let me know. I will explain. Okay. These are the logic functions that I have all mentioned. What are these logic functions? And the extra thing that you should know that in the XNOR gate, other than this notation, you can write it like this: the XOR B, and XNOR is you can get draw this the XNOR B and get the complement. So other logic functions that I have mentioned while we are discussing about the logic gate. Okay. So now we are going to remember about the Boolean operations. Sorry. So in this part, we are going to know about the the most common Boolean operations. Those are sum, product, and complement. So actually, these are very similar to the mathematical arithmetic operations, but they are only simple changes happen. So therefore, you should know this thing. So in the sum, you can see when the input is 1 and 0, and the 0 0, you always get the answers like the more normal mathematical arithmetic operations. But when the sum is 1 plus 1, that the output of the system is 1. So there you should remember what that means. Normally, the Booleans operations are deals with 1 and 0. That means with binary. So therefore, the answers cannot be exceed 1. That means it can be 0 or 1. So therefore, here it is not 2, and the Boolean sum is 1. And the Boolean product that you do not need to bother with this. Why? Because this is similar to uh, the normal mathematical product. So it's 1 to 1. 1 into 1 is 1 and 1 into 0 and 0. That means if there is any input is 0, that you get the 0 as the output. And the complements that I have mentioned you before, that the complement of the 0 is 1 and the complement of the 1 is 0. Okay, so these are the Boolean operations. And let's see what is the order of these Boolean operations. So you know in the arithmetic operations that you use BODMAS, the cut of division, multiplication, addition and subtraction. So like that, this is the order of the operations in Boolean. So that's mean in the Boolean algebra, uh, you have to do the complement at first. So that means if there is a complement in any expression, Boolean expression, that if you are going to simplify it, that first you have to do the complement part. So then the next one is the Boolean. Next you have to do the product, and finally you want to do the Boolean summing part. This is also really similar to the mathematical arithmetic operation order. So you can see an example. Uh, Here, just try that. You have the answer also. Uh, so here in this part, you can see uh, one. Sorry. Uh, Here you can see 1.0 plus 0 plus 1 then, and get the complement of it. So there you can see that the first thing that you have to do according to this order is the complement part. So therefore, by this part that you have to get 0 plus 1 uh, is 1. So you know this complement is kept to this bracket. So therefore, we have to get the answer of this bracket and get the complement before doing other sums and the products out of this complement. So that means sometimes you can understand. You think why we are doing uh, the sum inside this bracket, but by this order of operation means that the complement of that means if there are products and the sums are out are in the outside of this complement, that you have to do it after simplifying this complement. So therefore, in this part, you can see 0 plus 1 is 1 and you have to get the complement. So that is done here. Then you can see how you can go to the answer. Then the next part is you have to do the product part. So it's 1 to 0 is 0 and 0 plus 0, the answer is 0. So like that, please give me the answer for this one. 1 plus 1.0 complement and tell me what is the answer. Here's all of you get the correct answer. It's 1. So you can see here 1 plus, and first you have to do this operation. It's the mm, just simplify the bracket. So therefore 1 into 0 is 0, and then you have to get the complement of 0. So therefore it is 1 plus 1, but the answer is not 2. 2, it is 1. So this part is very simple. Uh, and let's move on to the next one. So these are the Boolean identities. So that's mean when you are simplifying any Boolean expansion or any expression, that you can use these Boolean identities. So the first one is the double complement law. And also I want to remember that when you are doing a simplification, that means when you are asked to do any simplification, uh, that when you are simplifying those problems, that you want to mention what is the Boolean identity that you have used in simplifying that. Okay. So the first one under the Boolean identities is double complement law. So there that's mean if you get the complement of if you get the complement of x, it's like this, is the same input. And the next one is idempotent law, and there if you get the two outputs as the two similar inputs. So actually that you should know this here by this notation x means it can be 1 or 0. So that means if you get the complement of 1 and the complement of it means 1. And if you get the input as 0, that it means the complement of 0 is 1. And again the complement of 1 here is 0. So that's why mentioned by this x. So it is not just a number, it's a variable. So that variable is we can give the inputs as 1 and 0. So the next two is idempotent law. That means x plus x is equal to x, and x product x is also x. So please, I think it's better to write down these Boolean identities. So no matter that I have shared the presentation is with you. Then when you are doing the simplifications, that you can uh, use these identities by looking at uh, that slides. But in your exams, that you have to remember these identities. Uh, so then the next one is the identity law. So normally the 0 is considered as the additive identity, and the 1 is considered as the multiplication identity. So you know the x plus 0 by the additive identity, the input should not be changed. So therefore x plus 0 is equal to x, and by the multiplication identity, uh, in the multiplication operations, the input is not changed. So therefore, x dot 1 is also equal to x. Then the domination law means 1 and 0 get the domination in the operation. So if x plus 1, whether x is 0 or 1, you get the answer as 1. And in x dot 0, whether you get uh, any input as x, but the final answer is 0. And in the commutative law, that means that you can interchange the two inputs. That means here y also can be 1 or 0. So here x and y means for as there you can give uh, 4 input combinations for this by x and y. So the commutative laws means in addition and the subtraction that you can use this. You can interchange those input. X plus y is also equal to y plus x, and xy is x dot y is equal to y dot x. Uh, so then the next law is as a associative law. So that's mean that if there are 3 inputs x, y, and z, that the x plus the bracket of y plus z. That means if you do the simplification y plus z at first is also similar to if you do the uh, bracket part of the x plus y at first. So that means actually this is means you can understand it's here x plus y plus z is equal to x plus y plus z. So when you are simplifying this, that you can select any part. So that means if you can select uh, the simplification y plus z at first, and then or you can use x plus y to do at first. So no matter. So by the associative law, both are same. So like that, it is also similar to the product. So x dot y dot z. Uh, so it's also similar. The associative law is similar as the addition. And in the distributive law, so this is somewhat differ with the normal uh, mathematical arithmetic operations. So that means in the maths you can see, not in Boolean algebra. So if there is x is into y plus z, so you only can do the distribute the bracket as x dot y plus x dot z. So here you can see like the mathematical uh, operation that you can do the distribution of x into y plus z. But in the maths that you know, but if there is x plus this formats part and x plus y z in bracket, you cannot distribute this one because the answer of this one is x plus y z. So there's no any change in mathematics. But in the Boolean algebra, that you can distribute this. So this, you can see y dot z is a single term, and you can distribute it by using this plus sign or the O. So here in Boolean, in Boolean, you can express this as x plus y, and the product inside here is similarly kept it out, and then get x plus z. So you should remember you can only use this simplification in Boolean algebra. So do not use in the normal mathematical arithmetic operation. That is wrong. දැන් ඔය මේ සමහර අය ඉන්නවා මේක මැත්ස් වල පාවිච්චි කරනවා එහෙමනම් පාවිච්චි කරන්න එපා. කෙලින්ම වැරදි. හැබැයි Boolean algebra තියෙද්දි, so in the Boolean algebra that you can use it. There's one message that it's mentioned about the can we do the simplification using Karnaugh maps? Uh, so Karnaugh maps is not dealing with these identities that actually it is yes that you can use the Karnaugh maps in simplifications, but normally that we are using the Karnaugh maps to get the Boolean expansion from a given truth table. So I will do it in the next part. And before that, you have to know about what are these Boolean, the basics of this Boolean algebra. Uh, so the next Boolean identity part is uh, the Morgan's law. So here you can see when we are getting the complements, the all the inputs are also gets complement, and the complement of product, that means the complement of O, the complement of N will be O, then the complement of O will be N in the De Morgan's law. Uh, and then the next one is absorption law. So when there are when you have the addition of two terms or product of two terms, that if all the two terms contains a single input, so you can see that in the both terms here, this one and these two terms contain x. So therefore, by the absorption law, that you get answer as x. So and also in these two O terms, so here is x, and here is x plus y. And in both terms that you could find x, so therefore by the absorption law that you get the answer as the x. So these two are the unit property and the zero property. So unit property is the addition of one input and its complement is always 1, and the product of any input and its complement is always 0. So actually these all are the Boolean identities, and this is duality is somewhat differ. Now you know some identities to use uh, in your simplification. So those are double complement law, idempotent, identity, domination, commutative, associative, distributive, De Morgan's law, absorption law, unit property, and zero property. Uh, so by that, that those are the Boolean identities. So other than this, this part is you can see it's the duality. Duality means uh, it's just like the interchanging. So you can see in the by the De Morgan's law that you can see the duality. That means that in the duality, in the but in the De Morgan's law, what you can see uh, when you get the complement, the all the inputs complements inputs gets its complement. So you can see x o sorry x and y here. The complement of x and y the, is the complement of s. That means not x or not y. But in the duality, that it is similar as the De Morgan's, but these inputs do not change. So you can see the dual of x and y or 0 means, so here x kept as x, but the sums will be products and products will be sum. So therefore here x and it is x plus, and here you can see y plus 0, but here y kept here y, and plus becomes the product, and 0 comes as 1. So this is the dual of uh, x and y or 0 is x or y and 1. So this is how you can obtain duality. Actually, the duality is that you can, by this example, the duality that you cannot say like this x y plus 0 is not equal to x plus y dot 1. And why is there's duality? So, but in the De Morgan's law that you can use this uh, equal sign. But if you get the complement like this, that mean if you get the complement according to De Morgan's law, you can write it as x dot plus sorry, yes, x here dot, it will be plus y dot 1. So like that, by the De Morgan's law, that you can write this. But by the duality, it just say that if this input is exist and the dual of that input also exists. And De Morgan's law එකේදී කියන්නේ කෙලින්ම මෙහෙම කම්ප්ලිමන්ට් එක අරගත්තට පස්සේ ඒක සමාන කරන්න පුළුවන්. හැබැයි ඩුවලිටි එකේදී කියන්නේ සමාන වෙනවා කියලා නෙමෙයි. මෙන්න මේ ඉන්පුට් එක x and y o 0 කියලා ඉන්පුට් එකක් තියෙනවා නම් මෙයාගේ ඩුවල් එක. ඒ කියන්නේ x o y and 1 කියන ඉන්පුට් එකකුත් තියෙනවා කියලා. මෙයා එක්සිස්ට් වෙලා මෙයා එක්සිස්ට් නොවී තියෙන්න බෑ කියන එක ඔය කියන්නේ. තියෙනවා නම් දෙකම තියෙනවා නැත්නම් දෙකම නැහැ. හැබැයි ඒක මේ डी මොගන්ස් ලෝ එක පටලවා ගන්න එපා. So actually duality you do not find in the arithmetic operations වලදී වැඩි use වෙන්නේ නැහැ. ඒකින්ද ගැටලුවක් නැහැ. But you should know what is the duality. Okay. So these are the Boolean identities. Uh, එක නෙමේ 0 නේද කියලා අහලා තිනවා කවිදු මට චුට්ටක් කොතනද අහන්න පුළුවන් නම් මේ මයික් ඔන් කරලා මට චුට්ටක් විස්තර කරන්න. ඔව් දැන් ඩී මෝගන් එකේ හරිනේ ඉතින් මේ මෙතනදී බිංදුවේ කම්ප්ලිමන්ට් එක. කියන්නේ මේ 1 කියන්නේ මේ බ්‍රැකට් එකේ තියෙන y plus 0 වල කම්ප්ලිමන්ට් එක. ඒතකොට නම් y වල කම්ප්ලිමන්ට් එක o එක n වෙනවා 0 වල කම්ප්ලිමන්ට් එක 1 වෙනවා. So okay. Mm. So okay, before going to tables, that I will give you some examples to do. So the first pass, so do simplify this one. So f is equal to x plus x dash y. So by this dash sign, it's also we can notate the complement x. So that means you can say x. You can write this as like this also. No matter. But I'm asking you to just simplify this expression by using the laws. දැන් අපි ඔය laws ටික දන්නවා. laws ටික හරියට ලියලා simplify කරන්න බලන්න. simplify කරලා ගත්ත answer එක මට දාන්න chat box එකේ. Yes, I got many answers, but can you show how you get the sum of you get the answers? Why? Please keep a photograph of that one because normally the answer is x plus y. And also, uh, please keep an image of you that if you get the x plus y, so you can upload it in the chat box because I want to identify what's the wrong with that. මට චුට්ටක් මේ ඒ ඔය උත්තර ගත්ත කට්ටියගේ ඉමේජස් ටිකක් කියලා දාන්න බලන්න. මොකද මේ වයි ගත්ත කට්ටිය ගොඩක් ඉන්නවා. කොහොමද එයාලා අරන් තියෙන්නේ කියලා එතන ආන්සර් එක ගැන වෙනස වැරද්දක් තියෙනවා මම ඒක මෙන්ෂන් කරන්න. හරි මට පුළුවන්ද කවුද? අ මානුක පුළුවන් උත්තරේ දාන්න ඔයාගේ උත්තරෙත් කවිඳු කෞශල් ඔයත් දාන්නකෝ දෙන්න චුට්ටක් දාන්නකෝ. එතන මම බලලා කියන්නම් ඔයාලා වෙනස් වෙන්න ඕනද මොනවද කියලා. උත්තරේ හදපු විදිහ මට චුට්ටක් දාන්න. Okay, now I got why some students has got the answer why. So it's the method is wrong that you have mentioned. So you have used. So here, uh, but most of you that use the associative law incorrectly. So therefore, you can see the associative law use only we can use when the all terms are as sums or all the terms as multiplication or as products. So, but in this case that you cannot use the associative law, but you can use the uh, the distributive law. Uh, so how you can see the distributive law that it's the mix of products and sum. So there what you can do is here this is the product of x prime and y. So that's mean then you can use the distributive law. So here x plus x dash into x plus y. So when you are simplifying that you have to mention in the bracket what is the law. So it is use uh, distributive law. අනිවාර්යෙන් මේ සිම්ප්ලිෆිකේෂන් කරද්දී ඔයා මොකද්ද සිම්ප්ලිෆයි කරන්න පාවිච්චි කරපු ඩෙන්ටිටි කියන එක මෙතන ලියන්න ඕන. Then you get the answer as 1. So 1 into x plus y. So by what? X plus x dash y 1 කියලා ගත්තම මොකක්ද? Unit property. So you have to mention it as the unit property. But you have to simplify this one. Is 1 and x plus y means x plus y. So therefore this also obtained by, you can see this identity law. So you have to mention it as the identity law. So got this? So in this when you are simplifying this, you not only get the marks for the operations, but also is every of knowing this identity also get marks. So therefore you have to do the simplification very smoothly and steps one by one, and each and every step that you have to mention what's the law that, or the what is the identity that you have used in simplification. Okay. Oh, please raise your hand if you do not get this. මේක තේරිච්ච නැති කට්ටිය ඉන්නවද උසන්? So I will give you another one. And here that please keep not just give the final answer, but give your answers. If you can upload, please upload the answer as an image with the steps. Okay. So simplify this one is equal x plus x prime dot x z plus y prime dot z. So try. අපි හදලා නැද්ද? හදාගන්න බැරලා හිරලා හරිනවනම් හදපු තැන වෙනන්ද හරි දාන්න. Okay, I get many answers, but I think it's better to do it by me. Uh, so let's see how we can do it. Yes, here in the first steps that you can do, uh, x plus, here this part is 0, and you get 0 z plus y prime dot z. And so here how you can get this? This can be get by the 0 property. Then you get as next step, you can eliminate this x plus 0 plus dot. It is done with what? Identity law. So you can remember the identity law here. Uh, Sorry, it's not identity law, it is domination law. This is my bad. So you can get it's not the identity, it's the domination law. Uh, this is the domination law. And after that, you can get by using these both terms as X. So it is the identity law. X plus Y dash Z, and this is the identity law. So now that you can see, you cannot simplify this after this one, because just you can use the distributive law, but you cannot do any further simplification. Uh, so therefore, by getting this answer, you have to stop the simplification part. Got it? But though there is no more much simplification that you have used three laws, if you get a problem in the exam like this, but just you get the marks in using these identities. Identities හරියට use කරනවට ලකුණු හම්බෙනවා. Okay. So I think now you can understand this part, and let's move on to the next one. So this is uh, how we can do the truth table. So you know that we want to draw truth tables, and uh, that we learned about the truth tables for the main logic gates. But here we are going to draw truth tables for logical functions or logical expressions. So let's see how we can do it. Uh, so before moving to this part, I will do a simpler one. So if you ask to draw a truth table, things you are asked to do a truth table for A dash plus B. So now, first you have to identify how many inputs are there. So how many inputs are there? There are two inputs. So if you can do any further simplification, you can do it, no matter. But if not, you have to use this one. So as there are two inputs, what are the inputs? How many inputs combinations that we can have? Inputs two, input combinations. It's 2 into 2. So then that means that the inputs are A and B, and you have to get the output F. So input combinations that you will have four combination. So 0, 0, 0, 1, 1, 0, 1, 1. So these combinations are, you can find by turning the decimal number into binary. So here 1, here 2, sorry, here 0, 1, 2, 3. That means when you write these decimal numbers in binary, that you get these combinations easy. So then what you have to do, just get the answers. So that for before getting the answers, if you need, you can draw a intermediate step as a dash. So it is not necessary. Actually, in the exam, you only get if you get any if you get a truth table to fill, you only get the marks for the final result. And also, these combinations should be right in order. Okay, so now you can see you can have an intermediate step. If not, you can write the answers, the output directly. But I will do it with the intermediate steps because then you can ensure your answer that you have done it without any fault, any errors. Okay. So as these inputs are A, now we are going to obtain the truth table for this expression. So here A dash should be 1, 1 and 0, 0. So like that, now you can add these two and get the final output. So A dash plus B is here, adding these two, 0 plus 1, 1, 1, 0, 1. So this is the truth table that you have to draw. Got it? So this is an example. So like that, now you can refer it. And now you have to do the truth table for the following function. Then make it a function eකට truth table එකනේ. So now you know there are three outputs. So three inputs A, B, and C. So you have 2 to the power 3 combinations. That means 8 combinations. So you have to write them in order from 0, 1, 2, 3, 4, 5, 6, 7. And these all decimal numbers are converted into binary and you can use it as the inputs. So here 0 is 0, 0, 0. 1 is 0, 0, 1. So like that. 5 is 1, 0, 1. So then this is how you can view the inputs in order. Then according that you have to get the output. So now uh, draw the truth table and please send them through the chat box as a message. So if you are unable to upload an image, so then you can give the final 8 outputs in order. Images upload කරන බැරි කට්ටිය ඉන්නවා නම් මේ මෙයාගේ outputs 8ක් එනවා එයාට මෙන්න මේ order එකටම ලියලා chat box එකට දාන්න. So okay. So these are the answers that you can obtain. Uh, and also that as I remember, you do not need to write these intermediate steps. So if you can directly write the answer, yeah, no matter, write it. Okay. So let's move to the next part. Uh, so this mean how we can write a Boolean function, that will be Boolean expression. So how we can write a Boolean function for a given truth table. So this is can be done in many forms, but actually before going to that terms, that one, I want to make you familiar with the previous ones. මේ කලින් කරපුවා ටික හොඳටම ඕන මේ පාස් ටික යන්න. එතකොට මම චුට්ටක් වෙලාවක් දෙනවා ඔයාලට මේ දැන් නෙමෙයි. පස්සේ ඊළඟ ලෙක්චර් එකට කලින්. එතකොට ඔයාලා අනිවාර්යෙන් මේ ටික ස්ටඩි කරන්න නැත්නම් පස්සේ කරන ටික තේරුමක් නැති වෙනවා. හරි. So here we are going to write a function for the given truth table. So before that, we want to know how we can do it. So we can do it by using the SOPs and POS. So that's mean uh, the SOP means sum of products. Uh, so you can see it with the expansion. So after going to after doing these two parts, I will explain the previous one. So here, just remember the by we can write the function for a given truth table by using this sum of product and product of sum. Okay. Now let's see. Uh, Now you have given a truth table here. For this truth table that you are going to get this answer. So this is actually this is the Boolean function for this truth table. So sum of product. So here you can see the each term is product. There are three inputs that each term contains each term have three inputs and all are as product. So these are also called as min terms. So this is sum of product, or you can say sum of min terms. But then what's happened? These all terms, min terms, added and get the sum as the function. So therefore, this is why we call it's sum of products. So let's see how we can get the sum of product. That means how we can obtain the function using the truth table. So, okay. Uh, so before this one, I will show another notation that how you can use in truth tables. Uh, so first, let's see this one. So this is how we can write a truth table in short form. දැන් මේ කතා කරන්න යන්නේ sum of product එකයි product of sum වලින් truth table වල functions explain කරන්න යන්නේ. expansion එක ගන්න යන්නේ. හැබැයි ඊට කලින් මම චුට්ටක් මේ කොටස කරලා ඉන්න බැලුවේ. ඒ කියන්නේ truth table එකක් අපි කොහොමද short form එකකින් පෙන්නන්නේ. So here you can see. We can so here I think you can see the truth table with two inputs, and so there are sorry, with three inputs, and there are 8 input combinations, and there are 8 outputs. So when you notate this function with the sum of product, you want to use this notation. So here that means f of ABC, function of ABC, that means A, B, C are the inputs. And here you can see these are outputs, so you can use this as the equal, or it is no matter. Here sum of product, so it's sigma sign, and you can see we can use the order, notate this table like this. Then you can see when you are getting sum of products, you have to consider the true values. 1, here 1, and 1, 1. So that's mean when you are giving the inputs in order, in correct order, your outputs are the output at 0, 3, 5, 6, 7, 0, 3, 5, 6, 7 are true. That means when you are considering sum of products, that you consider about the true values once. Then if you consider the product of sum, there you have to consider the false value. That means 0. Here you have to take 1. So now let's see. So when you are writing the product of sum, you have to select the outputs with zeros. Then you get here f of a, b, c, a, b, c inputs, and this is the signs of product of sum, and the product of sum you give the zeros 1, 2, and 4. Here you can see 1, 2, and 4. Okay, now I think you understand how you can give a function in short form. Got it? So just remember, for the sum of product, you have to consider about the true values. In the product of sum, you have to consider about false value. Okay, now again let's go to the previous slide. Okay. So before please notate this function by using the short form. So I want the answer for in both sum of products and product of sum. So please give me the answer. මේ ලියන විදිය තේරුම් නැද්ද? Please raise your hand if you do not get this. මේක තේරිච්ච නැති කට්ටිය ඉන්නවද සර්? Yes, I got an answer. Yes, good. Let's see how you can write the answers for this. So here, So to write the sum of product or sum of min terms, that you have to consider, get the sigma and select true values. The true values are at here 0, 1, 2, 3, 4, 5, 6, 7. So the true values are at 1, 2, 4, and 6. And you can write it as also a product of max terms, that means product of sum. So here, there you consider 5 and you want to select zeros. Sorry, I got wrong here. This should be 0 and this part is 1. So this is 7. So here you get 0, 3, 5, and 6. Yes. This is how you can notate this. Okay, now for notation like this is the truth table and this is the function. So it is same as this one. But here you can see as you use this short form, the sum of min terms, sum of products. So you have to write it like this. So here we haven't used the product of max term. So therefore what you have to do, so you have to write this using sigma. So then let's see how we can obtain this. Now you know how you to use the notation. And please raise your hand if you could not understand this. තේරිච්ච නැති කට්ටිය ඉන්නවනම් කියන්න බෑ. So okay, it seems that not everyone get this. And let's see how you can get this expression. So for the sum of products, we always select 1. And there are 4 terms. So then how we can get? So f is equal. So for this one, you get A as 0 input, B as 0 input, but C as 1. But you should know, always when we are dealing with sum of product, that we want to consider 1. So we have to convert these inputs to true values. So what you have to do? You get prime A, prime B, and C. And this is the one term. One term is each you can obtain by one row. Then you have to add the next term. Next term is obtained by the next row, which have the true value as the output. So therefore, there you can have A dash, sorry, A prime, B, C prime. And also next term obtained in this row. So therefore, the A is 1, so you can direct light A, but other two, B and C inputs are 0. So therefore, that you have to convert them into ones using getting the complement. And then the final term, which should be A, B, C. So this is how you can get the function for a given truth table. So got it? Uh, so it's okay. Then uh, I ask you to obtain the Boolean expression. Or I asked you to obtain the Boolean expression or Boolean function for this truth table. I am writing it in the green color. So it is F equal uh, sigma. So so before that I use the short term. Wait. F of A, B, C three inputs is equal to sigma 1, 3, 4, 6, 7. So now you can write the answer and keep it in the chat box. Or then if any one of you do not get this, please let me know. Okay, I got many correct answers. So yes, let's see how we can write it. So there you write 1, 3, 4, 6, and 7. So that means you have five terms: A, B, C, A, B, C, A, B, C, C, and five sum of min terms, and then one. One is 0, 0, 1. So you can write it like this. And for 3, 0, 1, 2, 3. So here you can see dash, because just you want to convert this A into 1. 3, 4, 6, and 7. So this is how you can obtain the answer. So I saw all of you got this answer. So just you can see. So there should be five min terms, and so you can get this. So there are only three inputs. So these all should be with A, B, C, and according to that you can select what are the true values. Then you have to convert the false values to true values by using the prime or the complement. So this is how you can uh, get the answer, the sum of products. Okay. Uh, so in next part, you can have the product of sum. And so this is can be done in two methods. The first one is you can, for the both methods, you have to select the zeros to get the product of sum. Uh, just give me 1 minute. No, good morning, Sandeep. Uh, හරි ඔව් එතන ඊමේල් එකේ ඉෂුව එකක් ඇවිල්ලා තියෙන්නේ. මේ එතන චුට්ටක් එතන ඔව් මම පර්සනල් ඊමේල් එකට දාලා තියෙන්නේ. එතකොට එහෙනම් චුට්ටක් ඒකට පාස්වර්ඩ් එක දාන්න පුළුවන් නේද? ඔව් හරි හරි ඕකේ. හරි ඒක ගැටලුවක් නැහැ. ඔව් හරි හරි. එහෙනම් එහෙම දාන්න. හරි ඕකේ හරි. හරි ඕකේ. Oh, yes. So for the both methods to get the product of sum, you have to select zeros. Then what you have to do, you can write the sum of min terms, sum of products, that means the previous one, for this one and get the complement. So here you can see the f dash is given, get, so f prime, get from a prime, b prime, c prime. So now we are going, we are writing this for the sum of min. sum of products. Then now I don't go to explain this one because you know how to write the sum of product for a truth table. Then what you can do, you can get the complement of both sides. Then using the De Morgan's law, here you get the complement of the complement f is equal to f. Then when you are getting the complement, according to this De Morgan's law, that you will get this answer. And also you can directly write this answer. How? Just that first I have mentioned the first method. Now I'm going to explain you the second method. So in the second method, directly you can write this answer. So what you have to do, select the zeros and then write the product of sum for the zeros. So here you have to consider all the zeros. That means if there are ones, that means true values, you have to get the complement and convert it into the false value. So here you can see the first one is f. You can directly, there are four terms of product as there are four zeros, and or as there are three inputs, all are made with A, B, C inputs. Then what you have to do? If there are zeros, no matter. So for first one, all are zero. So therefore A, B, C. In the second zero, so you can see this A is zero, but B and C are value one, true value. So therefore you have to get the complement and make it false. So therefore you can get the complement. And in next one, the next zero, the third one, you have to convert this A and C into zeros. So get the complement of A and C. And for the final zero, that you have to convert A and B both to the zeros. So therefore, this is how you can obtain the product of sum. So you can use it. For the both methods that you have to select zeros, and for the first method that you can write the if prime and write it as the sum of products. And also in the second method, you can directly write this answer using the zeros. So this is how you can simplify the truth tables into functions. Got it. Okay. So then I will actually I have explained all the things. So here, and now I am giving you a question to practice. So I have shared this question with you, but before the next part of the lecture, that you have to practice these things. So this is a one method that we can obtain the function for the truth table, and the other one is Carnap, and I will do it in the next lecture. So I have shared these slides with you. So before the next one lecture, that you should have to give the answer for this part. So now it's okay, and it's time to wrap up the lecture. So please let me know If you have any confusion, uh, so please clarify those things, because as I mentioned you, this is you get a question from this part, and you can score 100% in that question. So therefore, uh, actually, do not take it easy, but you have to practice these things. Uh, so now it's okay. It seems that you have no any question. So I will inform you the time for the next lecture. And thank you for joining the lecture. Have a nice day. Bye. I will end the meeting from now.